Hi, everyone. Thanks for joining us over the web during pandemic. I hope you and your loved ones are safe and healthy. My name is Ashok, and I'm a product manager. I love technical disruption in existing markets, as well as building products from scratch. That's why I'm in CNN right now, building next-gen products in markets which are either emerging or don't even exist. Having said that, today I am going to share a few learnings from the time I built products in the voice or smart speaker platforms, namely Alexa and Google Assistant, when I was in Headspace. Quick shout out to Headspace. Love you guys, and thanks for making Headspace free for all unemployed Americans and frontline workers. This is really, really amazing. So what's the agenda today? I think the goal for me is to help you with the basics of voice product development. After this, you'll be able to understand concepts and speak the language of this new tech, even if you're not building anything. We will talk a little bit about voice user interface, a little bit about the key technologies involved, and then basics on Alexa and Google Assistant, which will help you feel confident about the space. So what is voice UI? Before we answer this question, let's delve a little bit on the history and evolution of this technology. Anyone remembers this or recognizes what this is? Yeah, you may be right. This is the mouse, the first version of the mouse. So Doug Engelbart, the father of the mouse, recommended watching this 1968 iconic demo in San Francisco known as Mother of All Demos. He built out this little mouse, which paved the way for a next-gen UX and user interface, basically, which helps us interact with computer systems. This is interesting. Why? Because the evolution of human-computer interface is very important for us to understand how we arrived at a voice user interface. With each recent decade, we have seen a new form of human-computer interface emerging quickly and become very commonplace. Each step brought a delightful moment when we discovered what we could do suddenly. Click with a mouse, pinch and zoom with your fingers. Now it's time for voice. Typing usually is the primary mechanism that we are all used to, yet most English speakers type only about 40 words per minute. Can you beat that? Can anyone tell me at what rate do we speak? We actually speak thrice that rate at 130 words per minute, and read at about 6 times that rate, which is 250 words per minute, and listen even 10x that, which is 450 words per minute, which means that voice is much better than writing. So voice is frictionless and faster. But before we get into that, I have some more inputs about how it cannot be as fast as we think it is. So why this evolution? Mostly it's about rapid innovation of speech technology and machine learning. Apple and other hardware companies have started the smartphone supply chain, which is very important because it paved the way for any hardware innovation. Google, Amazon, Facebook, and Apple, they all have resources for research. They've dug a lot of time into this field, and that's what they came up with it. And of course, there are other theories around why this has evolved very quickly, especially from Amazon's side, because this becomes a way for platform neutrality. Like Apple owns smartphone, Google owns search, so Amazon is trying to own the voice platform ecosystem. But then you'd ask, why voice? Good question. 1 in 4 people in America now own smart speakers. And the growth of adoption is steeper than cell phone and smartphone. I think this is very important for us to see how quickly this tech is adopted and what it can lead to. So this is like a symptom of the underlying affordances the platform is providing, which will explain a little bit. It is also ubiquitous. Right now, around 75% of households have voice speakers. So that's great. So it also provides, as I mentioned, new affordances and new user context. So seamless access, as I mentioned, with voice is a frictionless medium or user interface, right? Most people are now gravitating towards, I want X, Y, Z, wherever I am. So this is very important because if you look at a situation when a user don't need a mobile phone or a smartphone, example, waking up in the morning, going to sleep at night, driving, or at group settings, I think this is very important. So accessibility, screenless experience, these are interesting things. Of course, smartphone assistants. Most assistants are right now, as you can see, are tethered to your living room, which is Google Assistant and Alexa. But right now, they are also available in smartphones, so they'll go with you. So this is actually a great reason why one should pay attention to this video. So what is voice tech? So voice platform technology is composed of two different things. One is a smart speaker, a hardware device, plus speech recognition technology, which recognizes that you are speaking to it. And then second one is an assistant, a conversational technology that helps you execute tasks, if not goals. A little bit interesting thing to talk about or think about is the conversational technology piece, which is very important. So roughly it's divided into three areas: automated speech recognition, ASR, natural language processing, NLP, and natural language generation, NLG. Automated speech recognition is basically transcribing audio to text, and natural language processing is taking that text and working out what command it might be in it. The error rates have gone down from 33% in 2012 to under 5% in 2017 for recognizing words. So that's actually a great reason why we should pay attention to the progress of this technology. As I mentioned, natural language processing helps us understand those commands in a way that machine can understand. The third feature or the third technology is NLG, natural language generation. It is a natural language processing of generating natural language from a machine representation. So which means that if there are certain things that the machine wants to relay back to a user or a human, how can it construct a human readable sentence? So we'll get to a little bit of this in the next slide. So as an example, let's take this. When I was at Headspace, I built this product. And let's take this example. So when a user says, Alexa, tell Headspace I want to sleep, how Alexa basically processes these and gives you what we want. So this first step is it detects a wake word such as Alexa or OK Google using some beamformation mics that filters out other noise and only pass the wake word to us, to the device, sorry, to start listening to what instructions the user provides. This is a big technology area in itself. And if you're interested, you can read up on that. When the wake word is detected, Alexa then listens to the raw audio input and sends it to the server for further speech recognition processing, which starts in identifying or transcribing the text that you said from the audio, and then NLP picks it up. Now, NLP helps us figure out the commands, as I mentioned, from those natural sentences, such as Alexa, play Chainsmokers playlist from Spotify, as an example, and return an appropriate message to the user. One of the subfields of NLP are NLU, natural language understanding, which converts that unstructured input, such as a natural human sentence, and converts it into a set of instructions. So the machine reads this instruction in a structured format to perform an operation. Machine only knows structure, right? In the world of Alexa and Google Assistant, we call it fulfillment, fulfilling the intent, basically. Machine generally finds it hard to understand context, pronunciation, synonyms, meaning, what's car could be also say, we can call it car as a ride too. So it's hard for machine to understand those things. But simply put, the field of NLU, natural language understanding, is to help address that. The field of search has been using natural language understanding for decades. The other subfield that I mentioned of NLP is also NLG, natural language generation, where the machine learns to use the structured data to present it in a human readable format or understandable format with correct syntax and grammar. For example, when Alexa replies back, playing the playlist, this is Chainsmokers from Spotify. So this is basically how they construct the sentence. Now, the key challenges, these are three challenges which is very important. Human hearing is complex and nonlinear. We don't listen to a sentence or process a sentence in a linear fashion. Human memory is needed to exploit long-term context. So when we have a conversation, actually, we use a lot of things that we reference from past. So we need memory. We need to store a lot of data to have actually a great conversation. And lastly, human attention is required to relate specific inputs to outputs, meaning that human attention should be, should be used in a way that is actually used in a way that, it pays attention to only certain things which are important and relevant, and then responds to those things versus anything else. These things are really, really hard to replicate in machine. So that's why it's so hard to create a conversation or a conversational product. So having said that, there are a couple of things that's very important to learn is the VUX, or voice user experience best practices. But before that, probably we should know a little bit about the basics of how to create these things. So Alexa basics. So what's the analogy to an app in voice? So in Alexa, we call it skill. How do you open the skill? You use an invocation phrase, which is basically headspace is an invocation phrase, right? Which is slightly different from a skill name. A skill name could be like headspace meditation, and the invocation would be Alexa play headspace. And it's slightly similar to search and web. For example, we use the word request phrases like give me, tell me, open. These are all request phrases, the way we write queries in search. And they're implicit and explicit utterances. Sometimes you say things like, Alexa, help me feel relaxed. That's not an explicit utterance, it's an implicit. Like, find me the best skill to help me feel relaxed, right? Whereas explicit will be, help me feel relaxed using Headspace or something like that. So the next set of basics for us to understand is three things: intent, fulfillment, and slot. So let me take you through an example. But before that, let me also give you some definition. So intent is a goal or task that a user wants to do, such as ordering coffee, finding a piece of music. So in the previous example is play everyday meditation, or play Chainsmokers playlist. These are intent, basically. Now, fulfillment is a service or an API or set of logic that handles an intent and carries out the corresponding action. So for example, you saying, hey, Alexa, play Lady Gaga, leads to Alexa fulfilling the request of playing, which is an intent, and something called slot, which is a particular intent, like you want to play Lady Gaga. So Lady Gaga is a slot. And now here, basically, if I don't specify where you want to play it from on Spotify or Amazon Music or any other services, it basically defaults to the user defaulted version. Sometimes when you don't specify anything, it plays from Amazon Music too. So those are important things to understand. A little note, there's something called built-in intent you'll hear a lot in Alexa, in the world of Alexa. It's basically an intent built by Alexa, which isn't fulfilled by any third-party apps. It's Alexa fulfills it all the time, or Amazon fulfills it. So for example, when I say Alexa pause, it pauses what I was listening to. It doesn't matter which app or skill I'm using. So that's basically, or Alexa cancel. So those are basically built-in intents, so that these intents work out irrespective of any app that's right now running. Having introduced a few basic concepts like that and those words, I think it makes it easier to explain a little bit of the design principles. But before I delve into it, if there's any questions, if you have any concerns, please let me know. Great. All right, we'll have more questions towards the end probably of the presentation. So let's dive into this VUX design principles. These are very important because a lot of times web or other areas that are, or even iOS and Android native app, we got used to, accustomed to the design principles by way of working on it, building on it. Since this platform is new, I think this matters for us to share some of the best practices that we learned along the way when we build our products. The first one is be concise. Users cannot see anything. Users process things, very quick, very fast. If they see things like on a web page or on an app. So here you have to be very quick, very fast, so that users can process things faster. Introduce yourself. Again, they can't see you, so it's good to introduce an app or skill for the first time when you are, and it probably it probably holds true for all platforms too. The third one is fulfill intents immediately. Again, they can't see you, or they cannot see the loading icon that we see in the world of graphical user interface, app or website, right? Here they cannot see the loading icon. So here you have to basically make sure that you have to fulfill intents immediately as possible. The latency should be very, very low. Otherwise, people don't realize, they think it's their problem, they think it's the internet's problem. So those creates a lot of cognitive load and issues in a user. Reprompting is very important. It's good to reprompt to ensure that a user heard all the all the prompts or all the options that you have given them to pick from. Uh, Adding variety. I think sometimes welcome messages, if they are the same, it gets stale and it gets boring and sometimes annoying too. So it's always good to have different types of welcome messages as much as possible. It also creates some sort of a delight for a user. Help and error messages. This is very, very important. One of the key things that people don't realize is that a lot of times error happens. Either the user said something or we didn't process the things really well. So at that point, it's not a good user experience when they cannot see things. They don't get feedback from us. So it is really a must for us to help users. If not for users for anything else, I think Alexa's certification process is so stringent. This is absolutely required for you to look at all edge cases and error cases and fulfill those error messages. Detours and invalid inputs. Sometimes users give invalid inputs, not because they are trying to play around with you, but also they genuinely said something, or the ASR picked something else from the user, right? At that point, when a user gives invalid inputs, we should probably use this opportunity just to delight the user by using some APIs like fallback intent, where if anything is not very clear to Alexa can then call this API or call this intent and then fulfill them in a nice way. For example, hey, I'm still learning, something like that. Account linking and upsells. To get personalized content, you may want your users to link their account or sign in simple words. So Alexa and Google Assistant has developed features working with early access partners like Headspace in the past to help you with this. It has become really, really seamless and very easy right now. Do not mention intent that aren't available. If you do not have content available on the voice experience, but you have them in the mobile app, talking about it on the voice experience can be considered as an advertisement, and that will not pass a certification process. And in general, if you don't have anything, why mislead users? So this is very important as well. Last principle, represent your brand through copy. That's very, very important. A copywriter is actually your visual designer here. The voice user experience VUX designer is actually a designer who's working on the interaction and the conversation. But if I have to put an analogy for the web world, the visual designer here would be the copywriter. So use the words that represent your brand. Any questions? These are a lot, but I hope that this can help you build your first experience really well. Okay. So a little bit of a dev considerations. So dev considerations are basically development considerations. I just shortened it to dev. Are important for you when you start off building your first skill. So you should know a little bit of these words. So there's something called authoring tools. So authoring tools are basically, they help you build, the skill itself, whether in Amazon or in Google. So there are two types of them. One is called modeling, the other one is called dialogue and response tool. So modeling tools are, for example, Alexa Skills Kit or AOG, Actions on Google Console, which helps a developer build an interaction model, basically a language model. How basically you make your conversations, what are your decision trees, what are your state machines. These are the words that you'll hear a lot if you work with engineers when working on these modeling tools. And dialogue and response tools are basically, probably you would hear a lot about dialogue flow. That's an interesting tool that you'll get from Google Assistant. Basically, it helps developers to install and build the language models and define the modeling tools. So these two work really well together. I don't think as a PM you need to get into nitty gritty, but if you want to tinker around and play your own and build your own first skill, simple skill, I would encourage you to do that. So one example I can show you before you get started on modeling is figure out your intent slots and slot values. Remember, as I mentioned, intent is basically to do something, a verb, right? And the slot is something specific that you want to do. So in this question, in this example, basically, this is my handwriting. I was trying to figure out, like, a skill to order or find a good restaurant, basically pick a restaurant. So the intent is to basically pick and find a restaurant, right? So the question is, Alexa, what is a good place to eat in the Bay Area? So great, like, I think the intent is picking a restaurant. The slot is Bay Area, which is one is the location. The other one is also, if I ask questions like, Alexa, find me a Greek restaurant. So the intent is again the pick a restaurant, but the slot is Greek. So as an example to abstract it, so slot is basically restaurant type, and slot values are Greek, Indian, Chinese. And then you'll also find slot synonyms. Synonyms are very important. If you want your skill to respond quickly and fast, you have to have a dictionary of synonyms like Greek food, Mediterranean food, moussaka, baklava. These are part of all Greek food, right? By the way, I love Greek and Indian food together, both. My husband is Greek, so this is an example. All right, so now the question is skill accuracy. So a lot of time PMs and developers, when they build products on this platform, go through endless nights thinking about, how do you optimize the product? And to tell you the truth, a lot can go wrong, right? Practically everywhere. So a skill accuracy is a measure of how correctly the skill fulfilled an intent. And let's see what kind of errors or where these errors can be. So the first error can happen with ASR, basically automated speech recognition, as I mentioned. Did Alexa or Echo, Amazon Echo, process the pronunciation of that user correctly before sending it to cloud? People who are not native English speaker like me initially found it really hard to interact with Amazon Echo or Alexa. Right now, things have improved drastically. The other problem that can happen is NLU. So did Alexa really figure out the right intent or slot values? So when I pass a command like, Alexa, help me find a Greek restaurant in Bay Area, did Alexa figure out the intent correctly, like find a restaurant, the slot value, the Greek, or the slot value of location, right? So that a lot of error happens there. And that's, again, another innovation, another development happening in the world of machine learning. NLG accuracy, has Alexa accurately picked the right fulfillment for intent and slot type? So, well, constructing sentence is one thing. I think Alexa does it really well, or even Google Assistant does it really, really well. However, what if the intent was fulfilled by a wrong, content or wrong API? So that's also important, right? Not just NLG, but also fulfillment is the issue. So Alexa looks at restarts and reprompts as indicators of error. In order to recover from failures, we can leverage something like a confidence score, based on which we can reprompt real time, which is important, right? You should know where, if an error occurs or if there's a confidence issue, right? That's only when we can retry or reprompt something. So as developers, how can we better design our experiences to avoid reprompts and restarts in the first place, right? So we can do so by looking at something very interesting, which is looking at transcripts. So sometimes you can look at the transcripts of actual conversations without having a user directly a personal identifying information of a user. You can actually look at transcripts, and those can help us a lot. Couple of things I would say is for you to look at is, one is something called dashboard.io. It's a product, but also there can be other analytics tool as well. So this tool basically helps us read these transcripts of conversation, which is really great. Second thing you can also do here is something called Intent History API, which was released a couple of months or years ago. Basically, it doesn't have any context or about the conversation, but it has a history of all the utterances, all the wake words, all the pre-NLU stuff. So actually, if you look at this history, this can help you a lot in understanding the context behind what was something said and why the reprompts happened. One pro tip for developers who don't get actual signals from actual users, they can actually whitelist devices for running beta tests for dog food. We have whitelisted devices for running beta tests where you can actually get all the signals from users or testers or QA team as well. So that, if you get those raw files, then that's much easier for you to understand ASR and NLU issues. Which one isolate, is it the ASR issue or is it NLU issue? Very few folks spend a lot of time in tweaking the accuracy for the skills. However, skills like song names, trivia, where proper nouns are used, needs a lot of tuning and testing. Best practices for such skills are, update sample utterances and expand your custom slots. What does it mean? So for example, the way I use an utterance is like play Chainsmokers from Spotify, right? So I can also say start the playlist Chainsmokers from Spotify. These are different utterances, right? Each utterance has, as I mentioned, a request phrase: play, give, tell me, start. So try forming a dictionary of all these request phrases. Try forming a dictionary or synonym library for all the intents. For example, playing a song, playing a playlist, so on and so forth. Also, look at your custom slots. For example, right now in the Greek restaurant or Indian restaurant kind of example, there's only one slot there, which was a Greek or Indian, right? But you can also expand your slots to locations, like which location you want, Greek restaurant in the Bay Area, right? So those are basically will help you build a better skill. This can get faster in the future when Alexa decouples the interaction model from language model, which I think they have done recently, so that you can expand this custom slots with synonyms and not change the interaction model at all by just keeping a dictionary separately from your interaction model. This will unlock a lot of value for users, especially when you don't need to certify your skill over and over again when you make a change in your synonyms or in one of the custom slot values. Entity resolution, this is a big word. So basically what it means is that how do we ensure Alexa understand the intent correctly? So as I mentioned in the previous slide, you can do a lot of things like expand your custom slots, update sample utterances, have a synonym library. One of the interesting things is that for skill accuracy, we need to make sure that the language model covers the synonyms, the third thing, which is so important. However, Alexa, now I think Alexa provides us with some built-in synonym resolver for understanding utterances such as, for example, get me a cab versus get me a ride. So as different utterances for the same intent. So I think that puts the onus less on the developer to build your own, like, let's say, list of sample utterances. I think if you use this feature, entity resolution from Alexa, and an equivalent one for Google Assistant, you don't need to then do this, get me a ride or get a cab, yourself. I think they will resolve it and help you resolve it on their side. Natural utterances, this is very important. So how does Alexa figure, Alexa, do Y versus Alexa, ask X to do Y, right? So which means that Alexa, help me feel relaxed, or Alexa, ask Headspace to help me feel relaxed, right? So how does Alexa figure this two out? So just like the world of web, there are head queries and tail queries, right? In the world of smart speakers, only a few skills are known to people. So people might not know that Headspace is on Alexa. You cannot see the apps there on the home screen, right? There's no screen. In that case, most of the time, users invoke a skill through a natural utterance, such as Alexa, help me relax, without using the word Headspace. This is called name-free skill interaction, which is very important. So Amazon also had launched a service called Can Fulfill Request. It's a feature And Google has something called BII. So they do the same thing. Basically, that feature helps collect real-time inputs from skills on the ability to fulfill a request. Then they handle disambiguation, meaning that, is this right or is this wrong or is it a duplication, and arbitrate between multiple skills and improves routing of the intents, which means higher quality traffic to your skills and better customer experience. This topic needs a lot of research and work. As you can notice, the skill discovery is one of the biggest problems in the world of voice. Just like Google published a set of like guidelines or best practices for search engine optimization, right now there are best practices for skills on the voice platforms as well. I would highly recommend if you can read about BII in Google Assistant and can fulfill requests in Alexa. Screen devices. I think screen devices have a lot of potential to help users. I think all the issues I mentioned about using voice, yes, voice is fast, but also voice doesn't have a visual layer, and human beings also are very visual. Human being processes things very quickly when they see things, right? And our auditory memory is also not really great. So screen devices helps a lot. So Amazon has been working on developing a markup language. I think they have also released a few versions in the last few months, which is similar to HTML and CSS. Google has been working on the screen devices as well. They call them smart displays and canvas. So these are from using templates to using high-level components and HTML. You can actually have a whole range of solutions for building associated, I would say complementary experiences on screen devices. I would say a couple of things important for you to understand here or think about is test your designs for distance. Echo Show probably has a range of 7 to 10 feet, whereas Echo Spot even has a shorter range. Use the surfaces for additional hints. I think it's very important. For example, if you help users educate in the screen devices, things like, do you know you can say, Alexa, tell Headspace I'm ready for bed. So you can actually help people remember these utterances so that they can use them to fulfill any of the needs they have. And lastly, you need custom analytics. You can use custom analytics like Snowplow or any event logging engine to track interactions in addition to the analytics tool that is provided by Amazon or Google. I would also suggest looking at like external tools like dashboard.io or any other tools, similar tools. A lot of typical analytics data that are provided by these consoles in Alexa and Google Assistant are around unique users, unique interactions, retention cohorts, interaction paths, skill activation, and as such, they are very reporting-based analytics and aggregated. But if you want to make real-time decisions or personalization, you need to like build up, event logging in your skills. With that, I would leave you with Q&A and this funny meme around voice. I hope you did enjoy today's presentation on voice. Please look me up on LinkedIn and we can have a conversation if you have any questions. And of course, I'm ready to answer any questions right after this presentation. Thank you so much. Have a great day ahead.